Okay, so for this problem, it's going to be a collision in two dimensions. We have our car that's moving east at 17 meters per second, and one that's coming south, 15 meters per second. And just drew this to kind of have a better idea of what the collision might look like. So before the collision, we know their masses and we know how fast they're going. Well, so we know each of their momentums, their initial momentums. Car 1, car 2, that's P, car 2. So when they collide, they'll draw in and look kind of like this. Based on the directions they're going in, we know it's going to be in like the fourth quadrant. So your X will probably be positive. Your Y will probably be negative. Okay. Anyway, getting off of the trig. Just getting on a tangent. Get it? Anyway, so when they collide, okay, in the east direction only, so in terms of a graph, this would be the X component only. This is what it would look like with the conservation of, the conservation of momentum, due to the law of the conservation of momentum. So I wrote there to remind myself this is in the east direction only. So this is only the horizontal component. We can combine them based on our angle and what we know to find the momentum. So what we're gonna get is, for in the X direction, 7.73 meters per second, and in the Y direction, same thing, except we're going to do sine because this is dealing with only the Y axis. So let's see, conservation of momentum. Okay, so here in the Y direction, I did the same exact thing. We get 8.2 meters per second. So then let's look at what's that going to look like. We can use our Pythagorean theorem. We find out that the overall velocity is 11.27 meters per second, and that's going to be after they collide. To find the angle, we just need to inverse what we found for the meters per second, and we find out that it's 11.27 meters per second and 46.7 degrees. So basically, like what we thought.